Okay, hello IB Biology. We're going to try this new lab here, and this is going to be the effect of wind speed on plant transpiration. It's going to be a similar lab to our stomata lab, except this time we're going to go all out. We're going to make a graph and a table. You guys are going to do the data processing to its fullest, just like you would on your IA. We're also going to attempt to do a chi-square test, as well as a t-test on this, and error bars and trend lines. Now, we did these last year, but the difference is we've always used Microsoft Excel, and obviously I do not have access for that this year due to virtual learning, so I'm going to try to teach you this using Google Sheets. And this has been a learning curve for everybody, but if you follow this video, you can succeed. So I'm going to break this up into steps, just like you see here now, to make this easier. Let's go ahead and get started. Step one, clean your table up. So if you open this file, you will notice that I have all the data here laid out just like this. We're going to have to clean it up, and that means we're going to have to merge things together and also make the heading stand out. So first of all, let's go ahead and highlight everything, and that includes these blank cells down here because we're going to calculate the mean and standard deviation. Come over here to your borders icon, and by the way, in case you don't know this, you can click here and that will expand your menu bar if it's already closed up. But go over here to your borders icon and click fill borders like this. Next thing, let's go over here to your headings, and we're going to add a background color, fill color. You may pick whatever color you like. Personally, I prefer a darker color just to kind of separate it from the rest. And let's go ahead and highlight these here too, just because we want to make these stand out as well. Okay. Next thing we're going to want to do, let's go ahead and center this data. I like to have all my numbers centered, although this isn't really picky scientifically. It just kind of makes your paper look a lot nicer. Go over here to horizontally align, and you can change this to a center horizontal position. Next thing we're going to need to do is we're going to need to merge these cells and center them. So when you are creating these, you can just add a row in here by going to insert row above, and we can put another row up here. And that's how I was able to create this row and this row here. But now we need to merge them together. And to do this, I'm going to highlight these two because these are going to correspond to my independent variable. You're going to go over or highlight these two cells, and you're going to need to go over here to the merge cell button here. Click on this, and it should merge that into one single cell. Then, if you come back over here to align, you can get this to align in the center. By the way, you can actually come over here to vertically align, and this will push it to the top or in the center or in the bottom if you want to play with that, but I would just rather leave it there in the center align. Okay, we need to do that over here for the dependent variable title as well, because these are all independent cells. So let's go ahead and click on the dependent variable, and we're going to merge all of these cells together, columns B through M. I highlighted this. I'm going to come over here to merge cells, and now that I've merged, I'm going to go over and center it just like we did there. So overall, everything stands out and things are merged together properly. Okay, this next step is actually pretty quick. We're going to add units and uncertainties. We're going to go back here. So fan speed. First, we're going to need a unit. Always put your units in a parentheses like this. Sorry, I had to pause it. I'm getting a lot of background noise from other people in the house here that I was hoping would keep it quiet. All right, so when you put units in here, you're going to want to put these in parentheses. I've seen many people do this where they're putting units like this, like fan speed in centimeters or something. The problem is, think about it. This is inches. This is centimeters, and a lot of people will put like their unit in this. No. We want to put it in parentheses like this, centimeters. Okay. Now, we're not done yet because fan speed is going to be measured in revolutions per minute, RPM. So we know that everything below here is spinning at this amount of revolutions per minute. However, we want to know how accurate this is, because is this spinning exactly 240 times per minute, or could it be off by a few rotations? Well, to do this, you would need to use a camera or whatever means to do this, or look at the manufacturer box, or whatever you do to measure this is fine. But if you find that every time you measure it, it's off by maybe 4, so sometimes it'll be 240, sometimes it'll be 236, then you know this has an accuracy of plus or minus 4. So to do this, if you have a PC, you can do Alt 0177, and that gives you the plus or minus icon here. If you do not have this, you can simply just do plus/minus. So that will be another way. You can also go up here to insert an icon, but I'm going to save that and let you use that depending on your PC. Okay, so again, 01 or Alt 0177, and let's say we determine this was plus or minus 4 RPM. So we have a unit and our uncertainty with how precise our fan speed is measured. That means all of your numbers here, you can be sure that they are accurate to within 4 RPM. Now let's do our dependent variable, and that includes all of these fields here. The movement of a bubble in the capillary pipette, you should have read on the lab form. We're going to measure this after 20 minutes, and we're going to measure this in milliliters as our unit. However, if you saw in the lab report, this is going to be even more precise than this. The pipettes we're using are actually precise to a tenth of a milliliter, which means that all the numbers below you can be sure are accurate to within plus or minus 0.1 milliliters. So not only do you know that we're measuring this bubble's movement in a milliliter, we are precise to a tenth of a milliliter. That's why you want to have a unit and an uncertainty, okay? And again, every number here below reflects that. This next step, we're going to round to the same number of decimal points. This step is actually pretty quick here. If you notice that all of these so far seem to be already rounded to the same decimal points, but we have some here like 4, 7, 5, and 8. That's because these were input as 4.0, but as soon as we click off, it just rounds it back. And that's because, again, Google Sheets is not smarter than you. It thinks that 4.0 is the same as 4, but it's not, because 4.0 has 2 sig figs in it. 4 just has 1, and that's why we cannot leave it this way. To round this up, what you're going to do is you are going to need to come here, and you're going to highlight all of this data here that you want, and then you come up here to the rounding place, and you can increase or decrease how you want these to be rounded. But we are going to round these to 1 decimal place each, and that corresponds with our uncertainty because we said our measuring device was able to measure with that degree of precision. Okay? And now we're going to calculate the mean and standard deviation. And you've done this before, so maybe this is a breeze for many people. The mean and standard deviation, you can do this in many number of ways, but Google Sheets makes this automatic. And to do the mean, you click on a cell and type in equals average. Okay? And I'm going to go ahead and click on this here, the average that popped up. Now, notice it's trying to be smart, and I kind of don't like that it's doing this, but this is where you just have to be careful. Notice that it is picking cells B3 through K3. Make sure cells B3 through K3 correspond to what you're calculating, and if it works out, well then fine. Go ahead and hit enter, and it will calculate. Now it's trying to say, hey, I know what's going on, and it's going to try to autofill. But I'll show you how to do this one more time just to avoid that. Type in average, and again, make sure that it corresponds to that. If it is, you are good to go. Okay, and another way you can do this, it's a shortcut, but since this is technically an equation here, you can see the equation is up there. Just click on the cell, and you can simply copy that cell and highlight the cells you want the equation to be pasted, and then just paste it, and it'll calculate these here. And by the way, the reason you're not seeing those numbers is because they have a high degree of decimal places. So I'm going to move this over so you can see what really is happening here. Now, to do the standard deviation, same thing, except we're going to type in equals stdev. Okay? Go ahead and click stdev, but notice, unlike last time, the computer does not know what numbers it wants to use for the standard deviation. So without doing anything else, we're going to now highlight field 1 through field 10. Make sure you do not accidentally highlight the mean. A lot of students do that. And once you got your raw data, 1 through 10 fields, you can hit enter. And again, we'll do that here, stdev. And make sure the computer thinks it knows what we're doing this time, so it's already highlighted the second time around. And again, we can just keep on doing this, or we can just go up here to copy the cell, highlight where we want the next ones to go if it's a repetitive sequence. And of course, now that we've got these calculated, we need to round to the proper number of decimal places. Remember, the rule of thumb for mean and standard deviation is we are going to look at our raw data that was used to calculate it. And they were rounded to a 1 decimal place. That means we're going to want our mean and standard deviation to be rounded to 1 more decimal place of precision. And so you're going to come up here to this rounding tool here, and let's round it to 2 decimal places. And of course, I'm going to go ahead and center them just like this. Okay, this is the most redundant step of the entire activity that we're going to do, only because I'm just going to show you how a lab or creating a graph works. First of all, go up here to the zoom tool and shrink this so you can see things easier. Normally, when you make a graph, you simply just highlight your independent variable, and then you hold Control and go and highlight your dependent variable, which in this case is just the mean. We basically told the computer this is the x and this is the y axis to our graph. We're then going to go here to Insert Chart, and then you got to come up here under Chart Setup. You got to scroll to the top and change it to a scatter plot. Okay, so this is what we have. In fact, it looks all right. You can see it's plotted exactly as it should, but the problem is we cannot make error bars, whereas we could in Microsoft Excel. So I hate to say this, we've got to delete this and start over and do a shortcut, or not a shortcut, we actually have to cheat and trick Google Sheets in order to get it to do what we want to. So forget this entire step. We've got to do it a little more complicated this next time. All right, so the last step we looked at making a simple graph, but it's not going to work for this particular lab, although it depends on the type of graph you are making. So for your IA, maybe that would apply. This one, we're going to try to make an error bar and a trend line. So let's go back to here. And in order to do this, it's unfortunate, but we need to trick Google or Google Sheets into thinking it has multiple series. So I'll show you what I mean by that here. Now to do this, it's really annoying, and I'm sorry you have to do this, but we have to copy our independent variable here. And then we're going to go ahead and paste it down here. Actually, I'm going to do that again. I'm just going to use Control C here. We're going to go to Paste Special and just paste the values. That way it doesn't paste the equations or anything in here. And the mean and standard deviation, I'm going to go ahead and, actually I'm just going to copy the mean here like this. Control C, and I'm going to go ahead and move this over 5 spaces because I have 5 of these, row 2, 3, 4, 5, and then in the 6th one I'm going to go ahead and paste it here. You'll see why in a minute. And again, please paste this as a value, because if you don't paste it as a value and you just paste it as an equation, it's going to try to post the equation, but it won't know what rows it corresponds with. So you're just pasting the values, okay? And then it's kind of annoying because it doesn't know the decimal places, so you're going to have to go here and readjust this, of course. All right, here's what's going to happen. It's really annoying you've got to do this, but when you make a Google graph, it's trying to make separate y-axes, and unfortunately you have to do it in this or it will not know what to do. So what we're going to do is we're going to tell Google that 0.64 is its own series and it corresponds to all of these. And this isn't normally how you do it, but again, we have to trick and kind of hack Google Sheets to make this work. So what you're going to do is you're going to take each of these data points and you're going to put it next to where it needs to go, and we're just going to put it one over like this. Okay, you got to manually type these in here unless you want to copy and paste them. Okay, 0.734, 893, just like that. And of course, I am going to play with the rounding tool, although it really doesn't matter in this case. So now what we've done essentially is we've told Google Sheets that this is our x-axis, and this is one y-axis. This is another y-axis, another one, and these are called series. Essentially, we're creating 5 series, and each of these we can put their own error bar onto it. And again, you do not need to do this if you're using Microsoft Excel, but Google Sheets, unfortunately, is not smart enough, so we have to figure out a way to hack this. So here's what you're going to do now. You're going to click and highlight all of this, just like this, including this over here, because this is going to be a 6th series we're going to use to plot a trend line with. So go ahead and highlight all of this, and 5 series with the 6th one here, and now we're going to go ahead and insert a chart. Okay, and now we're getting an automatic suggestion. Yours may look different, but again, we don't care what it suggests. We're smart enough to figure out we want a scatter plot. Okay. And we're going to go ahead and move on down here, and we're going to play around. You can play around with these if you have to, because yours may look different than mine. All right, so we have our graph like this. By the way, if this option ever closes accidentally, you can always double click on the graph. You just have to click to a side here and this will pop back up. And make sure you have the scatter plot. What we're going to do now is we're going to try to put error bars on this, and we're going to try to plot a trend line. And I know this is really confusing. You can see we've got the x-axis, and then we've got the 6 series that we told it was supposed to have. Again, you're going to have to play with these down here, and you're going to have to do this on yours until it gets a rough, similar appearance as to what I have right here that's corresponding to our data that's before. And again, each color represents technically each of these individual columns, and the last color here, the blue, is actually overriding all of it. So really there's a color under each of these teal colors or whatnot. So here's where we're going to go ahead and go to Customize. And to do Customize, you're going to come under here and do Chart Style. Chart and Axis Titles. And for our chart title, we're going to want to go to Horizontal Axis Title, and we're going to give it this title here. You can actually click on this, highlight it, and copy it. And if we double click back on here, we'll get our chart title horizontal, and you can actually paste that and hit enter. Look, it automatically put it in there. Go to Vertical Axis Title, and we can do the exact same thing over here. If we highlight fan speed and highlight and copy it, we can come back in here to our Customize options and go to Vertical Axis Title and paste the Vertical Axis Title. You can play with this if you want to, but you can change the font size, the color, bold or not bold. I will let you do that according to your desire. But make sure you have labels for your axes as well. By the way, you can also click down here on the numbers and you can change if you want it to end at 1,000. I mean, it should be automatically lined up, but I'll let you guys decide if you want to do this. All right, let's go ahead and now go to series. This is where we're going to create the error bars, okay? To do the series, you're going to need to do these one at a time. And to do this, I'm actually unfortunately going to have to move this graph down here. And we're on series again. Go to data series 1. Data series 1 corresponds to this first column, which is really just 0.64, which really is this mean here. You're going to need to scroll down and do error bar for this first one. And we want to do constant because we don't want a percentage. And what we're doing is we're using the standard deviation as our error bars. So you click constant, and you're just going to enter that standard deviation. And I know it's annoying, but hit enter, and you should get an error bar that pops up there. And if we look, there's our error bar. It's really small, but it is there for that first one. Let's go ahead and do the next one now. You're going to go up to data series 2. And again, that will correspond to your second row here, that 0.23. And we want the standard deviation for that. Come down here to error bars, and you want a constant, so we're going to enter 0.8. It's our standard deviation. Okay, hit enter, and again, there's our error bar for that. It's a little bigger because it's a bigger standard error. Okay, I'm going to go here to data series 3, and again, we're now going to do 0.69 for this one, constant. If you have trouble, I trust you'll go back on the screen to see how I did this one. This next one's got a data series 4. If you see this fourth column, this series here, this is a big one. Big, or 0.278, that's a big error bar. Go to constant error bar, 2.78, and then and again, if you want to check it, look how big that error bar is for that one there. Okay, and our last one we're going to do here is data series 5, which is corresponding to this fifth column. That's 8.93, and we're going to use the standard deviation 0.92 that is next to this here. Okay. We're going to do 0.92 and hit enter on your keyboard, okay? There we go. You can see clearly the small standard deviation was that first series, and our largest was that fourth series. This is how we're able to custom add a error bar to each one of these, and you really are making your graph off this down here, and it's really annoying. Now, we've made our error bars, but do you remember we have a 6 series here? It's really this last column. And if you notice, it's all the data points and it's overriding all of these on the top here. We're going to use this entire 6th column, go to data series 6, and we're going to save it to make our trend line. And there you go. Click trend line instead of error bars. Okay? So if we look at the trend line, we can now change the color and the thickness. I usually like it to be a little thinner there just so it doesn't cover anything up. And you can choose this to your liking. Is it exponential, polynomial, logarithmic? Again, I think this graph is linear data, so I'm going to keep it just like it is. But again, you get to choose and decide. So as far as making a graph, that's really all there is to it. You can always tidy this up a little bit more, and you don't necessarily have to have these on here, but if you want to play around with clicking there and just hitting the delete key, you can get rid of those too. But if you get something like this, you know you did it correctly. We can see here that our data starts out down here. The movement of the capillary action is moving. I just noticed I made a mistake on here too. I have my title switched around here. So give me just a second here. Go back to chart and axis title. Not a big deal. I just have to put the horizontal in the wrong place. And that's because, you know me, I am multitasking, and there is nothing more dangerous than McGee multitasking. Okay. So that is a vertical axis title. So I'm going to go to the horizontal, and that is the fan speed. Okay. For RPM. Done. Same thing, I just switched my axis around there. Okay. When you are done with this, you are going to copy it and paste it and post it into your assignment. Okay, this next thing we're going to do, we're going to try to make it quick because we have done this in the past, but performing a t-test of the null hypothesis. Okay. First of all, I'm going to go ahead and clear the graph off because you can copy and paste it, and I'm going to clear all this out down below because we've already done it. We're going to go ahead and do a t-test, but remember, the purpose of a t-test is to compare any two sets of data, and I would recommend you do the control group and compare it to an extreme, which is usually the highest one or whatever number there is, but we want to know, is there a significant difference, okay? So the research question, is there a significant difference in bubble movement from the fan speed? We need a null hypothesis. In this case, there is no significant difference. On the other hand, we're going to need an alternative hypothesis, which is there is a significant difference between the two sets of data. Now remember, in order to overcome this, we need to reach our 0.05 threshold, and that is, of course, going to be the same thing with the chi-square test. But in order to do this, we simply just click on a cell, and you're going to hit equals t-test. Go ahead and hit t-test here, and it just wants us to give our two rows of data. But again, click the question mark. You're going to need to give one range of data, hit a comma, two ranges of data, comma. You're going to need to know if it's one or two tails, but like I said, always do a two-tailed test. It's much better, comma. And then it's going to need to know, is the data paired or unpaired? It's a 1 or a 3, okay? And if you look at this data, all of these columns are unpaired because you could swap them and sort them and it doesn't matter. So this is going to be a 3 for unpaired. Let's go ahead and do this. With it like this, we're going to highlight the control, raw data. Do not put anything else in there. Now hit a comma. Highlight this entire row of data, comma. We're going to do a two-tailed t-test, comma. And we're going to use unpaired data. Now, I'm not going to hit the 3 in there, but you would hit a 3. Well, I'll do it now. I didn't want to calculate this with everybody seeing here. And here is our value, 0.0, but actually it's not 0.0. We can increase the decimal places. And you'll see there's our number. It's just so small that we were unable to see it. By the way, remember, how many do we round it to? We're going to want to round it to one more sig fig than we have, and since these are our lowest data point is rounded to, actually in this case, just one sig fig, we're going to round our value here to one sig, whoops. We're going to round our data here to just one or two sig figs as a result, okay? It's a very small number, so you may need to play around with this in order to see the number, because otherwise it won't be, but there's your p-value. So what do we do with the hypothesis? That's for you guys to decide. Okay, so we just did a t-test of the null hypothesis, and it's up to you to figure out, do we accept or reject the null hypothesis that there is no significant difference between the control group and the extreme. But we can also do another type of statistical test on this data, and this is a powerful way for us to draw a conclusion, and that is performing a chi-square test of the null hypothesis. So what we're going to do now is I'm going to go here, and I actually created a whole nother table, and if you remember the chi-square test, it's set up just like this. And I'll make it like this here so it's a little easier to see, but really we want our categories, and we can use a chi-square anytime we have observed and expected categories here, okay? So, in order to do this, we need to remember again, what is a chi-square test exactly? And really, it's just, do you have expected data you can compare it to? Something you could have predicted ahead of time. And so it's pretty powerful, but again, it's really answering that same question about, is there a significant difference? Except, I'm going to change this a little bit. The null is there is no significant difference between observed and expected values. That's really the difference between this and the t-test. Whereas the t-test is looking for significant differences between two categories, chi-square is looking for a difference between observed and expected values. Okay? And so if there is a significant difference in whatever we put in these values, this is what we're testing here. So how can we ask this question here? Okay? Well, if we look at our data, we want to know, out of all of these categories, is there a significant difference between what these were and what they could have been if it was just random? Like, for example, if the fan speed had no effect on it at all, wouldn't you have expected all of these values just to be the same thing? Well, let's go ahead and test this hypothesis out. Go ahead and copy this, and again, we're going to paste this as a value because we don't want anything erratic popping in here. And I'm going to go ahead and center it too, just because it makes it easier to explain. Let's go ahead and get our observed values here, and that would be our mean. Go ahead and copy that and paste our mean in here, mean values. Okay, and again, it's annoying, but it keeps giving us different decimal places, so we're going to adjust it like this. Okay, so here's where it gets a little tricky, and a lot of people have struggled with this even last year, so I'm going to blow this up here a little more. How do I know what my expected values are? But again, think about the null hypothesis. If it was true and there is no difference between the observed and expected, these would all be the same. They would be random. And in order to figure out what this is, in this null hypothesis, we would just get the average of these. So I'm going to calculate the average of these above here. Okay, and of course it suggested it. It is correct, so I'm going to get this here. The average is 4.73. Okay, it added them all up and divided them by 5. So let's go ahead and copy this. I'm actually going to go ahead and put 4.73 in each of these here. Whoops, I don't know why it chooses decimal places, but I'm going to go ahead and copy, and I'm going to paste this in all the other rows there, 4.73. Okay? So again, think about what we just did there. We are saying if the null hypothesis was true, that there's no difference between these results here. We're basically saying it didn't matter what the fan speed was, we got the same movement in every category. There's no difference here at all. They were all the same. But the alternative hypothesis says, no, there would be a difference. And I got to be honest, if you look at these values, doesn't it look like it's not random? It appears to me there is something going on here. So a chi-square test is not always doable with a t-test, but in this lab, we can do both of these tests, and they really give you a powerful way to talk about a conclusion here. So I'm trying to show you how to do it. So what you're going to do now to do this is you're going to calculate, and I'm not going to do this for this video, but you're going to calculate O minus E, and then you're going to do O minus, basically this column here, O minus E, and then square it. And then you're going to take this entire column here, and O minus E squared, and then divide it again by E. Now, I am not going to do this for you, but when you're done, you are going to sum. Because I do want you to try something out for this lab on your own to make sure you're getting it right. Okay, you're going to sum this up, and by the way, the sum is technically chi-squared. That's actually where the name comes from. Chi-square is the adding of all these. Let's just say you did all these and you added them all up, and let's just say the number and I'm just throwing this out here. Let's just say the number we got was, let's say it is I don't know, 9.62 or something. Okay? Let's go ahead and work with that number, shall we? So you have your chi-square. What we're going to need to do now is we're going to need to figure out our degrees of freedom. Okay, and in this case, it's always n minus 1, the number of categories here, which is 5 minus 1. So in this case, we're going to have 4 degrees of freedom here, okay? Just 4 degrees of freedom. So here's what we're working with. This number right there, and we have 4 degrees of freedom. If you go to my manual that I posted for the class here under the chart, you can actually go to the far back page of this manual, and I have here how to do the chi-square test as an example even. But here's your table of critical values. So we had, I'll go back here. We had 4 degrees of freedom, 4 degrees of freedom, and we're going to look and see what is our critical value. Our critical value is 9.45 at 4 degrees of freedom. If we get anything bigger than that, we can say it is significant. So if we go back here, 9.45, and wow, I didn't even memorize that. That was just a lucky guess. It is bigger. Therefore, if this was my value, it would be significant. And therefore, I would conclude the null hypothesis is not correct, and there is thus a significant difference between the observed and the expected results. Clearly, there is something special going on here. You would then write that up in your conclusion. Okay, so I'm going to let you calculate this. You have to figure out what the exact values are. If you need help, please let me know and don't wait till the last minute.